This lesson is called 8.2, but it's actually from the high school book. So if you're going online, you want to go to the Common Core High School, lesson 8.5. The reason that I swapped it out was because this is a technique for graphing a parabola, and the official 8.2 that's in our book is about this thing called the focus. And while the focus is a very important thing about a parabola, it seemed unrelated to the other lessons in chapter 8. So I'm swapping it out, and I'm going to talk about how to graph using intercept form. So this graph, or this way to graph, is the quickest technique, or at least I think so, because it tells you exactly where the intercepts are. So if you know where the x-intercepts are, then you plot those points and you make your parabola. And the one thing that you need to know is where the vertex is. So the vertex is on the axis of symmetry. We know that. Here it is. And so if you plot your 2 points, or, for your quadratic, for your parabola, the axis of symmetry is halfway there. So this formula right there is just saying it's the halfway point between the two values. And you'd have to know the official y value so you can officially make the vertex. But once you have the intercepts and you have the vertex, then you just make the u and you move on. If you want to get more points, that you can do that, but it's unnecessary unless you're doing something more specific. So let's check out example 1. Here is the function that we have to graph, and we have to describe the domain and range. Now I'm going to take my function and bring it down here so that way I can show you where the intercepts are. So I've got f of x equals negative x plus 1 times x minus 5. So the intercepts are where the x values, where the y values are 0. So if you think back to what we did in an earlier chapter, this is 0, and then you solve each factor for x. Okay, great. So let's do it. Drop a line down each of the terms. Well, negative 1, right, that's what this is, negative 1, doesn't get solved, so it just stays. X plus 1, I'm going to shortcut. The x value would be negative 1, and here the x value would be 5. So what I want you to understand, and I'm going to go back up to the function, is that when you're looking in factored form or in intercept form, it's whatever you need to make the factor 0. So here, what makes the factor 0 is negative 1. Here, what makes the factor 0 is 5. So you don't have to go through this whole solving technique. You just have to understand that it's not 1 and negative 5. It's negative 1 and positive 5, because that's what makes the factors 0. All right, so that's exactly what I've done. Step 1, I've identified the x-intercepts. So the x-intercepts are negative 1, 0, and 5, 0. Then I have to find the axis of symmetry. Well, the axis of symmetry is halfway between negative 1 and 5. Well, halfway between negative 1 and 5, I'll do it algebraically, but you can figure it out yourself, would be negative 1 plus 5 divided by 2. So that would be a x value of 2. So the axis of symmetry is at the point x equals 2. I have to find the vertex, because knowing that the axis of symmetry is along the line x equals 2 doesn't help me out at all. I have to know where that actual vertex is. So wherever I see an x, I will plug in a 2 and see what I get. So f of x, my pen isn't working, f of x equals negative parentheses 2 plus 1 times 2 minus 5. So let's solve it. That gives me negative 3 times negative 3. So that gives me actually positive 9 when you go and do it. So you get the point 2, 9. That's where the vertex is. And then I'll draw the parabola. So I have all the pieces. Now I just have to graph it. So there are my 3 points, negative 1, 0, 5, 0, and the vertex at 2. And notice that if this is the axis of symmetry, it's halfway between the 2 points. And now just connect, make a U, or in this case an upside down U, because the A value is negative. If you didn't catch that, the A was negative. And just write the function on it. And that's graphing using intercepts. Before we move on, we have to describe the domain and range. So I'll do that over here. Domain is all real numbers, and the range is real numbers, but y has to be less than or equal to 9. How did I get 9? It was the y value of the vertex, and all the points were lower than 9. If you want to graph using intercepts, you can do that even if something is not written in intercept form like this. What you would do is you would factor it, and then you have it in intercept form. So let's factor, and I recognize from chapter 7 that this is GCF factoring. So f of x equals 2 parentheses x squared minus 4. Oh, now I have a difference of 2 squares, so I can keep going, and I get f of x equals 2 times x plus 2 times x minus 2. Hope you didn't forget how to factor. Now I have to identify the x-intercepts. Remember, it's what makes the values 0. So this would be negative 2, and this would be positive 2. Then I have to find the axis of symmetry. Well, halfway between negative 2 and positive 2 is 0. So that's an x value of 0. And now I'll graph that. But then what I have to do on that is find the actual vertex. So wherever I see an x up in the equation, I will plug in 0 and see what I get as my y value. So f of x equals 2 times 0 squared minus 8. F of x equals, well, I'll just write 0 because that's what it is. And so that gives me the point 0, negative 8 as my vertex. All right, so you have everything. I'd like you to pause the video and plot your values. Now, what you'll notice is that I put a dashed line through the axis of symmetry. It's not necessary to do that unless the directions weirdly tell you to, but I decided to. The final thing we have to do is describe the domain and range. I'll do that down here. The domain is all real numbers, and the range is real numbers, but y has to be greater than or equal to negative 8. How did I get negative 8? It's the y value of the vertex. Now down here in example 3, we're just going to practice finding zeros. And remember, zeros is another word for roots, which is another word for x-intercepts. So I'm going to drop a line down the factors because this is in factored form. And I'm going to solve, and I'm going to shortcut solving because we've done this already. X equals 1 and x equals negative 2. So the 2 points where this parabola would hit the x-axis would be 1 and negative 2. Now, in order to do letter B, you have to actually factor it. So, first thing is you always look for a GCF. So, I will pull out a negative 2, and I'm going to divide. I get plus 5x plus 6. So, I have to keep thinking what would be my pairs. That's going to be x plus 2, x plus 3. Don't forget the negative 2. Bring it down. And now I'm at the point where I can drop a line down the factors and solve. Well, negative 2 doesn't solve, so it just stays where it is. This would give me negative 2, and this will give me negative 3. So the roots for letter B are negative 2 and negative 3. Letter C looks like it's in factored form, but it's not because this is a difference of 2 squares. So I'm going to zoom out a little so I have a little more space, and I have to factor it. So h of x equals x minus 1 times, this is x plus 4 times x minus 4. Hope you remembered how to factor. So let's drop, and this would be x equals 1. This is x equals negative 4, and this would be x equals 4. So this would have zeros of x equals 1, 4, and negative 4. Doesn't matter the order you put them in. And then you say to yourself, wait a second, parabolas only have 2 intercepts? And the answer is you're correct, because this would be an example of what's called a cubic equation because it has 3 intercepts. All right, let's move right along to a little more graphing. So I've gotten rid of all of the steps from earlier. Hopefully you're remembering them, and if you don't, flip back and look at them. First thing you have to do is get it in factored form. So h of x equals, that gives me, I know it's a 3 and a 1, because that's the only pair, and I want to get a -2 in the middle, so there we go. So that's factored form. Now I have to get the zeros, so x equals 3, and x equals -1 are my zeros. Now I have to find the axis of symmetry. Well, the axis of symmetry is halfway between -1 and 3, so that's going to be at the value of an x value of 1. So I'll write axis of symmetry equals x equals 1. So that's where the axis of symmetry will be. I don't want to get it confused with an intercept, so I'm writing axis of symmetry. Now I'm going to plug in 1 into my function and get the vertex. So h of x equals 1 squared minus 2 times 1 minus 3. So h of x equals 1 minus 2 minus 3, which is -4. So I'll write vertex, because I don't want to get it confused, is at 1, -4. So those are the parts I need to graph, and let's do it. So they're my axes. I know my intercepts are at 3 and -1. My axis of symmetry is at x equals 1. Notice it's right in the middle. And the vertex is at 1, -4. And connect. Ooh, that's bad. And label your graph. Now, obviously, if you wanted a more precise graph, you would make a table of values, plug in some more values for x, see what you get out of y, and plot them, but this is good enough. If you have any questions, write them down and ask me when you come to class.